Linear and simultaneous equations. If you remember back to simultaneous equations, they are a pair of equations of which there are solutions to, and there's normally one solution. And that's because the ones we've been looking at are linear forms, so y equals 2x plus 3, and 2y equals x minus 5. What we've said is that those equations can be solved graphically, and they might look like that, and then the point through which they meet would be the solution. But that's because what we've been looking at are all linear functions. Now what we have here is now we've got a linear and a quadratic, and quadratic functions are these curves. What we can see is the options that we have is that a line can pass through it and there could be two solutions, or you could have a line that passes through it which is a tangent line, and that would give you one solution. So that would look maybe like that, where it's a tangent. Or you might have a case where there's no solutions, and that would be because the lines don't meet. So that could look like that. So the two lines don't meet and there's no solutions. So the way that we can use to solve this is a variation of the substitution method, where we make the x or the y the subject from the linear equation. So the linear is the one without the x squared. We then substitute it into the quadratic equation, and that's the one with the x squared. And what we should get is either one solution, which would be there, two solutions. And if we get to this stage where there are no solutions, that means the curve and the line, they don't meet. So let's have a go at example 10. So what we need to do here is we need to rearrange the linear and substitute it into the quadratic. But what we have is that y is the subject at the minute. We've got it in the form of y equals, so we don't actually need to do anything there. Had it been of the sort 2x plus 3y equals 7, then we would have had to have rearranged it. But because it's in the form of y equals, we can just launch straight in. So what we need to do is substitute the linear into the quadratic. So the quadratic is x squared minus 2y. But I know that y is x plus 2, so instead of writing y, I'm going to write x plus 2. So I've substituted it in, and that's going to equal 4. So we can then do x squared, expand the bracket, so everything inside the bracket multiplied by the term and the sign outside it. So we're going to have x squared minus 2x minus 4 equals 4. For quadratic equations, they must equal 0. So we've got x squared minus 2x minus 8 equals 0. So we've brought the plus 4 over, and it's become a minus 4 and combined with the minus 4 that's already there to get minus 8. To factorise, we use sum and product, or to solve it, we try and factorise it and we use sum and product. So the sum is minus 2, so that's the coefficient of the x, and the product this time is just minus 8. Had it been a 2x squared, then our product would have been minus 16. But as it's just 1x squared, we don't need to worry about that. So what we're looking for are two numbers that multiply together to give minus 8 and add together to give minus 2. And they are negative 4 and 2. So negative 4 plus 2 is negative 2. Negative 4 times 2 is negative 8. And because it's just x squared, we can go straight to the brackets. So our two brackets are going to be x, and then minus 4 and plus 2. So if that's true, then the first bracket must be 0, so x minus 4 equals 0, and if x minus 4 equals 0, then x equals 4. If the second bracket equals 0, then you've got x plus 2 equals 0, which means x equals negative 2. Now in the past, that's where we would have stopped. We've got our two x values, that would be it. But our equation is involving x and y. So what we need to do is substitute x equals 4 and x equals minus 2 into the linear equation, so that we can work out the corresponding y value. So we know that y equals x plus 2. When x equals 4, y is going to equal 4 plus 2, which is 6. When x equals minus 2, y is minus 2 plus 2, which equals 0. So our solutions are x equals 4, y equals 6, x equals minus 2, y equals 0. So just to verify that, I'm going to show you the graph. So we've got y equals x plus 2. So that was the straight line. And then we've got x squared minus 2y equals 4. So what we can see is the blue line is the quadratic graph, the red line is the linear, and we can see that they meet at 2 different points inside the keyboard. The first one is minus 2, 0, which was one of our solutions, and the other one was 4, 6, which was the second solution. Example B, solve y plus 2x equals 3 and x squared plus y squared equals 4. So the first one is my linear because there's no x squared or squared terms, whereas this is our quadratic. So what we need to do is rearrange the linear so it's y or x is equal to, and it's going to be easier to make y the subject because it's a single y. So if we move the 2x to the other side, we get y equals 3 minus 2x. And we can sub that into the quadratic. And what we get is x squared plus, instead of y, I'm going to write 3 minus 2x squared equals 4. Now I expanded the bracket. To do that, it's not just a matter of squaring the first and the last term. Anything squared means you're multiplying it by itself. So it's going to be plus 3 minus 2x upon 3 minus 2x. And that equals 4. To expand double brackets, we use FOIL. So we multiply the first together, then the outer, then the inner, and then the last. So we're going to have x squared plus 9 minus 6x plus 4x squared. So minus 2 times minus 2 is plus 4, x times x is x squared, equals 4. We'll collect like terms, and we've got 5x squared minus 12x plus 9 equals 4. Now for a quadratic equation, we need to equal 0. So if we bring the 4 over, we've got that 5x squared minus 12x plus 5 equals 0. To solve that, we need to try and factorize it. So if we try and do that, we get that the sum is equal to minus 12, and the product this time is 25, because we need to multiply the number term by the coefficient of x squared. Sadly though, there aren't any numbers that multiply to 25 and add together to give minus 12. So that means we need to use the quadratic formula. The quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we can identify our a, b and c. A is going to equal 5, b is minus 12, and c is also 5. So substituting those in to the quadratic formula, we get x equals positive 12. So it's minus b, but we were given b. So if b is negative 12, minus b is going to be positive 12. Then we've plus or minus the square root of b. Now, whatever the b value is, it's always best to put it in a bracket. So it's minus 12 squared minus 4 times 5 times 5 all over 2 times 5. So then x works out to be 12 plus or minus the square root of 44 over 10. Now the 44, that's negative 12 squared is positive 144. 4 times 5 is 100. So we have 144, take away 100. If you type it into your calculator, you should get that as well. And then that works out to be x equals 6 plus the square root of 11 over 5, or 1.86, or x equals 6 minus the square root of 11 all over 5, or 0.54. So we've got our 2x solutions. Now we need to work out the y. So we substitute those into y equals 3 minus 2x. So when x equals 6 plus the square root of 11 over 5, y works out to be 3 minus 2 times that, which is 3 minus 2 root 11 all over 5, or minus 0.73. And when x equals 6 minus the square root of 11 over 5, y is 3 minus 2 times x, which is 3 plus 2 square root of 11 over 5, or 1.93. So then those are the answers. Again, we can check this by plotting it as a graph. So we've got y plus 2x equals 3. And there's the graph of that. And x squared plus y squared equals 4. And we can look and see the coordinates of the 2 points. The first one is 0.54 and 1.93, and the second one is 1.86 and minus 0.73, which are the same as the decimal form of our answers that we've just worked out.